is by far the best way to make sure that the audience doesn't dare to ask any questions. So I've been here once more, I think a little over a year ago, and then that happened as well. So hi everybody, my name is Henry, and I was trying to get this slide here. I am a developer and architect. I live in the Netherlands on a very special location, namely Texel. Texel is the largest of the Dutch Waddeneilanden, the ring of islands going from the Netherlands via Germany to Denmark. It's where I want to live, and so I travel to my work instead of a choice to live near your work and then just happen to be where your work is. So tonight I will be staying at a hotel. Thank you for being here. I am not going to talk too much about myself. I'm going to talk about Microsoft Azure. So who's working with Microsoft Azure? So who knows this thingy, the portal? Who enjoys working in it? Okay, so the goal of today is going to be try and draw a small cross through your portal and see if we can find some means to do your work without. So the topic of today is the Azure Resource Manager. The Azure Resource Manager is the central location for accessing your resources in Azure. And when I say accessing, I really mean managing. So everything that you are probably used to doing through the portal, you can do, you're actually doing it through ARM. ARM is a REST interface that is below the portal. And we're going to explore that REST interface today and another set of interfaces that are built on top of that REST API. And one of them, I think the most interesting one, is of course templates, ARM templates. We're going to spend a fair amount of time on that. So there are 5 things I'm going to be talking about. First of all, a little bit about resources, how they are grouped, how you can interact with them. And we're going to discuss the topic of resource providers, as we know them in Azure. Then we're going to be talking about infrastructure as code, ARM templates. Then we're going to be talking about how to automate the rollout of these templates, how you can affect them in Azure. And there are 2 other things that also go through the Azure Resource Manager, and that's role-based access control, who can do what, and policy, what you can do. So role-based access control is with authorizations, who can do stuff, and policy limits or governs what you can do. So these are going to be the topics for today. And the first thing to understand, or is important to comprehend to understand the Azure Resource Manager, is that everything in Azure is a resource. Not just your virtual machine, also the hard disk below it, also the network interface, also the IP address, even a subnet on a virtual network is a resource. Everything is a resource. An alert rule is a resource. A dashboard is a resource. So everything that you know from Azure, all the things we will talk about today will apply to them. Now when we talk about these resources, there are 2 ways we can interact with them. We can interact with them through the management plane and the data plane. The management plane is concerned with creating resources, configuring them, setting an admin account, removing them, scaling them, monitoring them, these kind of things. The data plane is what you do when you want to connect to the service itself. For example, when you want to do a query on a database, that's data plane. When you want to create a database, that's management plane. When you want to see the number of connections per second, management plane. Now, where the line is differs a little bit per service, and for a number of services the line is a little bit fake, because some management operations you can do through the data plane or the other way around. So sticking with the example of Azure SQL DB, I can create a new database using T-SQL statements. So that is a management plane operation, but it's also accessible through the data plane. And today we will of course be talking about the management plane. So a little bit of background. Like I said, everything is a resource, except for people. So this is a really important point I want to make. For developers and our managers and the manager of our managers, we are not resources, we are people, but everything else in Azure, yes, and I know I'm being recorded, so people are now resources, but everything else in Azure is a resource. So this is a point that I'm making for a reason, and somebody knows why. So these resources in Azure, they can be grouped in what are called resource groups. They have no real meaning except for the fact that there are logical containers of one or more resources. Resource groups are then again grouped into subscriptions. Now subscription has a little bit more meaning because that's your unit of billing. There's a credit card behind every Azure subscription. And this is what we used to have up to a little over a year ago. And since then we also have another level on top of the subscription, that's the management group. So a subscription is always in a management group, and a management group can be in another management group, which can be another management group, etc. Up to 6 levels deep. So that's what the asterisk here denotes. Now the goal kind of is that you use management groups to mimic the structure of your organization, especially when you're an enterprise. You have, for example, a root management group, and then you have a management group Netherlands, a management group rest of Europe, and a management group rest of the world. And then you can apply things that go for all the Netherlands to that management group, even though there are like 10 subscriptions inside. So, for example, you can differentiate policies from billing by this. Another way to look at the organization of resources in Azure is by what we call the resource provider. This is the thing that sits in Azure and that manages that resource for you. The creation, the removal, the update, and also prevents, for example, configuration drift. See the resource provider as a REST API that you can call into to create, I don't know, a SQL server. With one small difference, and that is that you cannot call directly into that REST API. There is another REST API on top of it, and that API is called the Azure Resource Manager. And that's the thing that you can call into as a user. So this smiley, that is you, you're still happy, and you can work with ARM through the portal. So everything that you do in the portal goes through the Resource Manager. But you also have, for example, the CLI and PowerShell. Who likes PowerShell, by the way? Okay, better than Bash? Oh, okay. Another thing we can do is software development kits. For example, for almost every resource in Azure, nowadays there is a NuGet package that you can install to do management operations on, I don't know, SQL servers, VMs. Just another entry point into the Resource Manager. And finally, templates. And what sets templates a little bit apart from the rest is that all these things often concern themselves with one resource, while a template can also go about a group of resources. And if you really like vanilla stuff, you can also call directly into the Azure Resource Manager, which is just a REST API. Now you might be wondering, why would I want to do that? Anybody got a clue? Any idea? Guesses? Let's make this really interactive. Got a microphone. So,
they don't support yet in more options?
Yes, that's correct, the correct answer. So the Resource Manager is always the first place where a new functionality will surface. And from there on it might be adopted into the portal or into the CLI or in PowerShell. And what it also is, the CLI and PowerShell and portal are never almost all three completely on par. Because Azure keeps changing, keeps evolving, and the REST API is the only one that's always up to date, and for the rest, well, who knows? Sorry? So, now that we know a little bit about the makeup or the organization of our resources, if I show a URL like this, it's not pretty, but it should make sense to you. We can address every resource in Azure using HTTPS management.azure.com/subscriptions/subscription ID /resource groups, resource group name, providers, provider name, resource type, resource name. So this is a continuing pattern, and we can also specify an API version. For example, if the way we manage for virtual machine changes, instead of changing how the REST API behaves, they add a new API version. And if you always specify the version you are using, you are guaranteed that the behavior will stay the same. Should stay the same. Now, except for resources, we also have sub-resources, and in that case, the URL will extend like this, which shouldn't come as a surprise, I hope. Now, what can we do with this? We can create, for example, a put request to the location of a not yet existing resource So here we see the same URL build up, in this case for a service bus. So the first thing we see here is the name of a resource provider, which is called Microsoft.ServiceBus. From that resource provider, I'm going to use the namespace, and the name of the namespace is MySpace. And I'm just going to add a JSON document that I'm going to put to the URL. And put is for either create or update. And here I can specify the properties that are specific to that service bus namespace. So the properties change for every resource that you call. Now if I do this call, this is a thing that I might get in return. And I can keep getting the same URL and I will keep getting the same response. Except for example, things like the provisioning state. So when I do when I get the result from the put, when I start doing gets right away, this will be provisioning, and after a while it will be changed to created. So, who's still following me? Blimey. So, if you're not, because this is often where a lot of people get confused. So, the first thing that I want to point out is if you are ever wondering about all these resource providers, resource types, and properties of all these resource types, there's a reference for that. And there will be URLs later on. So this used to be pretty bad, but nowadays it's pretty good. So you can choose the resource providers. So I don't know, let's say I want to do something with SQL. Not MySQL, real SQL. Thank you. So when I open this up, I see that I can go to a thing called all resources. And then the first thing you will see is that it will show you a list of all the resource types that are provided by this resource provider. Another thing that used to be, oh there we go, is in the top of this URL you can see the name of the resource provider. So this is where you can find these values. Now for these JSON objects, they vary per version of the API. So let's choose one, I know the latest. And what you can see again then is that I can drill down into sub-resource types. So for example, we have a database that will always reside on the server. So database is a sub-resource of a server. So if I go to this one, this is the template that I can use. So here do I find all the properties, allowed values, etc., etc. This reference is nowadays almost always complete. Actually, let me let you in a secret. If there's a new feature about to be released on any of the big Microsoft events, if you go into this reference somewhere around a couple of days before the event, you might find something there that's going to be announced. And the more and more they develop in the plane. Okay. Now, all this REST stuff is not really convenient. I think it's really good to understand it because it will help you with the rest of the things we're going to see, but it's not a really convenient way of working. So one of the things we have is PowerShell. For who likes this, this is how you create a virtual machine in Azure. We have tab completion. This is the same thing in the CLI. If you're using anything but Windows, the CLI is cross-platform, so that's awesome. And this is what you can do, for example, from an SDK. Almost all of them are fluent nowadays. They're not completely up to par, but they're getting better and better at it. However, the holy grail of managing your resources in Azure is by using templates, in my opinion. Ooh. 1, 2, 3. Well, thank you. So what we can do is instead of calling into APIs, we can specify a template of all the resources that we want to have in Azure, hand it over, and Azure will make it so. No matter what the current state is, Azure will convert you to it, if it can. So templates are specified in JSON, and they have the following structure. First of all, you're going to specify schema. This is a really long URL that you're going to copy from another already working ARM template. It's the best way about it. Then you can specify content version. This is just for you. Almost all the world leaves it at 1.0.0.0. And then we have 4 sections that you have to fill in. Parameters. Here you can declare things that you want people to specify when they execute your template. So for example, when I'm going to template, I don't know, a SQL server and an app service, and I want people to provide the name of the SQL server, I can use it as a parameter. I can specify the type, string, int, enum, secure string, which will make sure that it's scrubbed from logs, etc. And things like a minimum length, maximum length, allowed values, these kind of things. Next, there's a section called variables. Now here I can specify one or more values that I want to reuse throughout the template without specifying them more than once. So they're not provided from the outside, they're kept within the template, often derived from parameters, but not passed from the outside. Then the third part, the resources. And as you look really clear, this is not an object, but this is an array, which means that one or more of these type of objects go in there. And these specify the objects or the resources that I want created in Azure. And this is where our knowledge of how Azure resources are built up going to help. Because this is always the name of a resource provider. And this is always the name of a resource type. And this is just the name that you want to give to the resource. And again, then we get the API version. So we know how these are going to relate to the URL of the resource. Another thing you always have to specify is the location. Because there are a number of locations in Azure. And what I'm doing here is I am using a special syntax to say that I'm going to go into a string part that should be evaluated by the resource manager. And it's going to find a function called resource group, which is going to call, which will return an object with a number of properties, including the location. And this is my preferred approach to make sure that all the resources in a template go into the same location. Because the worst thing that you can have is a database over here, an app service over there, and a big latency in between. Do we have a question? Shame, shame. So this is how we specify resources. Well, like I said, we also have sub-resources. So what you will see here is that the type will have a slash and a sub-resource type appended, and the name as well. So we don't have one thing, they both get one, what's called segment added. Another thing that we have to do for sub-resources is specify that they depend on the resource that they are going to go inside. Now you think that Azure can deduct this on its own. Actually it can, because when you don't add it, it's going to complain and say that you have to add this. So, but you have to make them explicit yourself. You're not restricted to containing your resources. You can also depend on something else if you want to ensure some kind of ordering. And the fourth section that you can add is outputs. These are things that are evaluated and the value is given back to the script, program, whatever, that is going to deploy the ARM template. Well, a final thing is there are a number of functions that I can use within my ARM template. We have parameters and variables. Well, you never guessed. These are used to look up parameters and variables. Next, we have resource group and subscription. Both going to return you an object with some details about the resource group and subscription. There's a function called resource ID. Here I can specify a series of segments. So first a provider name, then a resource type name, then the name of the resource. And this thing will make sure that it's all properly concatenated with just one slash, not two slashes, not 0 slashes. It's a handy function. I have string concatenation. There's many more. Yes?
The question was...
Oh yeah, let's do this one. Can I?
I'll be the picture.
Mm-hmm. Woo! There you go. Awesome.
You say the resource group or subscription depend on choice. What was the differences? Because I'm very new to this, so I see this depends on, and yeah, what's the differences?
So the difference between a resource group function and a subscription function?
Yes.
So at the start I said that every resource goes into a resource group, and every resource group goes into a subscription. So if I need information about the physical location of a resource, that's going to be subscription, resource group dot location. Mm-hmm. If I need the name of my subscription or the identifier of my subscription,
Yeah.
I'm going to call it a subscription function. So they both return different objects.
Okay, so it depends about what you're looking for.
Yes.
Okay.
And if you don't know what you're looking for, good thing there's a reference for that as well.
Okay.
So to answer your question, this is the reference for the template functions. Used to be quite not good. I have another S word for that. So let's see what the resource group offers me and what the what the subscription offers me. So this is what the subscript. Oh, I think I accidentally scrolled to the bottom. Here we go. What the subscription will give me is the ID of the subscription, so that's a GUID. The ID of the tenant, so that's the GUID that reference to the Active Directory that is backing the subscription, so where all the users reside,
Yeah.
and the display name of the subscription.
Okay.
The resource group, that is going to give me its name and its location. But I think there should be more. Oh, there's not.
Apparently that's the
Apparently
location.
this is. Sorry?
It wasn't resource ID. The subscription ID.
Excuse me, sorry, I don't.
You were looking for the subscription ID.
No, not really. I just thought that the list was longer, but apparently it's not. So this can really help you if you don't know the property you're looking for, or the thing you're looking for. For example, if I want to do, I don't know, concatenation, I can just look it up here. I get to the right place. If I am looking for, I don't know, substring, it's probably there. Nope. Oh, that's not fair because I know it's there. So let's go back to. So now I'm in the string functions, which I can access from the list of all template functions where I just was. Internet's a bit slow. Yeah, it's gonna work. String functions. There we go, substring. So there are a lot of functions available.
Yeah, I know.
And if you know what you're looking for, you can probably find it in here.
Okay. Thank you.
Sure thing.
I'll give this back to someone else.
Yeah.
Here
Oh,
you go.
actually, you're now entitled to continue the throwing at each other. So this is all good and well. So now I can start creating templates. But a thing that we have as developers is that we often have 2 or more environments where we want to effect our templates. Test, production, test, acceptance, production, etc. So this is where the parameters come into play. There are the things that I want to differ between environments I'm going to declare in the parameters. And one of the things that I can do is next to the template, I can have multiple parameter files. And in each parameter file, I can specify the values for each parameter, for example, relating to my test environment, or to my acceptance environment, or my production environment. That will work pretty well for things like scale size, naming, but it won't work for secrets. So for secrets, there's something else you can do. Instead of specifying the value, you can specify a reference to a secret in an Azure Key Vault to be used as the value. So this is how you can handle secrets.
How do you provide, if you want a template for Key Vault?
There is an ARM template for Key Vault. This is where you get into a bit of a chicken and an egg story. There are a number of things you can do. Some companies have like one centralized team that is responsible for managing all the secrets. So they are going to own all the key vaults and provide you access to one. It's maybe not the best pattern, but it's a pattern that happens. Another thing that you can do is if you're going to go greenfield, you can say, well, I'm first going to add my key vault to my ARM template, roll it out all the way to production, and then I'm going to add the secrets, and then I'm going to continue. That's one way. Another thing you can do is you can say, my key vault is going to be in a separate resource group. Might also be interesting for access segregation, separate from the default resource. But I think there is a better way. For that better way, let's make a really quick step to the reference for functions and go to list keys or list secrets. There is a function that I can call on almost every service that has secrets or keys to retrieve that secret in the template. And from once you call that function to have the secret, I can automatically have it injected, for example, to my application settings. Or what I can also do, a secret and a key vault is like everything else, a resource. So I can automatically provide it to my key vault through an ARM template. And we can combine that later on with another thing we will see, link templates, to create a really sophisticated solution that will have everything come together. So deploying a template is something like this. I'm going to connect to Azure. I can create a resource group. So it's really recommended to have one template correspond with one resource group. And the reason is this. Deployment mode. So what I'm going to do, I'm going to do a new deployment to this group. This is my template. These are my parameters. And then the mode is going to say complete. And this means that it's not only going to add to Azure what's in my template but not in Azure, it's also going to remove out of Azure what's not in my template. And that's a great way for cleaning up things that you don't need anymore. It's also a great way for messing things up if you don't know what it's doing. But it's really powerful because it's a great way for preventing configuration drift. And also, if you do this every, hour, and somebody spins up a really expensive Bitcoin mining machine, it's going to cost you a lot of money, and these things happen. It will be removed after at most an hour, so it can be beneficial. Since a authorization is also just a resource, it will also automatically clean up any authorization that you don't want there. So this is really powerful, also from a security and compliance point of view. But it's also risky. So I thought this was enough PowerPoint. Let's try to get you all awake again by opening up a tool we all love, Visual Studio. I hope we all love. Let me rephrase, a tool that I really love, Visual Studio. Because right now you might be wondering, how would I use this as a developer? So what I have is a typical solution that I'm going to, or can deploy to Azure. This is an ASP.NET Core project. And next to that project, I have what is create a resources project, which contains my two files, my template and my parameter files. This is a common thing and a thing that I would recommend where possible to have the infrastructure and the application that you will run on top of it together. So as a development team, you're going to take responsibility for the whole stack instead of relying on somebody else to provide it for you. Now, within Visual Studio, you can start typing JSON if you would like. This is an example. I have some parameters I declare, then some variables. And as you can see from this pretty tiny scroll bar over here, is this can get verbose pretty quick. For example, what I have here is a mouse cursor that's missing, and also an application insights instance. So this is pretty decent, small. Now what you can see is I'm putting in a variable for the name. I am looking back to the resource group to derive the location. That's it. Now we're going to create a service bus namespace. Also pretty small. I have to specify a size. Now a service bus namespace does not have that much value if I don't have a queue or a topic inside. So what I'm doing here, instead of having the sub-resource below, I am nesting the sub-resource within the resource. So I'm specifying another array of resources where I just add a JSON template as the other ones. And one of the things that you will notice is that for the name, I do not have to specify multiple segments. That's automatically deducted. Or deduced, I have to say. Me and my deducted. My wife is in fiscal law, so that's where deductions come from. I have plenty of them. And the type is Microsoft .servicebus/namespaces/queues, but I only have to specify queues since it's nested. I still have to specify the depends on, otherwise it will complain. And so we can scroll through this template and notice that all the resources are decently sized until we get to another one, which is a dashboard. So this is from line 200 down to 900. Yes, so this is pretty big. But on the other hand, it's really awesome that the thing that you are seeing almost appear on my screen, namely a dashboard just like this one, is specified as code. So as you can see for this one, I have a production and a test dashboard. They're precisely the same. My dashboards propagate from my test environment to production environment because they're specified as code. And I can do the same for alert rules, for example.
So that's where the download button comes into play.
Sorry?
That's where the download button comes into
For ARM templates, yes. We will. So you might be wondering at this point, do I really have to write all this JSON by hand? So my recommendation is yes. For the first 2 days, so that you really get them in your fingers, you really know how they feel, and from that point forward, start copy-pasting, stealing them. Yes, 2 days, 2 weeks, whatever it takes. But once you know how they operate, how they work, they're pretty good to work with. Yes, they can be cumbersome. Yes, there can be a lot of typing involved and scrolling, really a lot of scrolling. But once you know them, it's really powerful when you have to make small changes. And you can do GitOps on this, right? If you need to size up a VM, you're not going to go into the portal and make a mistake. Now you're going to go to the template in source control, make the change, have it peer reviewed, have it deployed automatically while you already go back to sleep. But we will see ways to reverse engineer them later on. Are there any things you want to see from this template, things you're curious about? So I've got it on screen right now.
You can also add, use the left bar, or
Yes.
is that useful?
Yeah, yes. So what you're correctly pointing out is this awesome thing on the left. Since my ARM template is JSON, it can be represented as a tree view with nodes. So that's what it's doing here. I have 4 top-level nodes. Let me use this one. Ooh. Ta-da! So there are 4 nodes here: parameters, variables, resources, and outputs that you have seen before. So what I can do is right-click on resources, go to add new resource, wait for a bit. Well, stuff is loaded from GitHub on the back end, I think. And there are a number of predefined resources here. So let's say I am really into logic apps. I'm a Falcon. I can specify a name of the logic app, and that will be added to my template automatically. And I can also find it here on the left. And since I don't want the logic app here, I can remove it again. So this tree view can be helpful for finding things and also for adding a limited number of resources that are predefined.
On the depends on, you said you have to define depends on, so if 19 resources, do you have to define the depends on field for all of those 19 resources manually, or does the ARM template infer that during deployment?
If you add them through the tree view, for example, you add a database on a server, it will infer them. You only need to specify depends on when things really depend on each other. So by default, everything goes in parallel. So if you have a template with 1,000 VMs and they can all deploy in parallel, Azure will, I assume to some extent, parallelize the creation of all these VMs for you.
Right.
So only when there is a strict dependency.
So if you've got a virtual network with subnets, you have to manually define those dependencies.
Yes.
Right.
So if you are really into creating virtual networks and virtual machines, etc. in the cloud, this is going to be really cumbersome. But one of the things that you can do is link templates. We'll talk about it in a little bit.
Mm-hmm.
But what you basically can do is make one template and reuse that. That's the question?
Yeah.
Anyone else? Okay, let's continue. Because there are some advanced options that I want to point out to you. First of all, you can have subscription level templates. What we've seen here is a resource group, or you can also have them at the subscription level, for example, to create resource groups. I'm not going to show those, because at some point it's going to be just more JSON. The same goes for link templates. Just trust me that there is a resource type, which is a template deployment, where you can specify a URL to another template so that you can use a template in a template. And we have packages about it. There's YoDoc. And that is, for example, the way that you can create a VM and two network interfaces and two IPs all together in one template and start reusing that template. Now, two other things that I will show you, because that doesn't involve JSON, is reverse engineering a template out of a resource group and the Resource Explorer. So, first of all, reverse engineering a template. When I go into Azure and I go to any resource or resource group, let's do this one because it's fun. There is a thing that's being renamed all the time. It used to be named automation, but now it's called export template. And you see it still works when I search for automation. So that's really awesome. Yeah, cool. So export template, this takes a while, especially for larger resource groups, it takes a while. And it will, for most of the resources, give me the JSON that is needed to create a resource. And I say for most of the resources, because it doesn't work for all of them. And what it will say here, it will probably give you it should give you a warning that it couldn't export all of them. Actually, it doesn't in this case, so that's not too cool. But it happens in a number of occasions, for example, for dashboards as well. So there's another tool you can use, and that's the Resource Explorer. If you have been philosophizing about the things we have seen, you now have come to the conclusion that your Azure subscription has just one gigantic JSON document, describing the state of all things that are in Azure for you. And a JSON document is a tree, which means that I can start browsing it. So here I have all my subscriptions, and within my subscriptions, I can browse to either all the providers. So let's see what I got from Microsoft Compute. So I've got 4 disks. But a little bit more interesting is going to the resource group. And for example, in this one we saw before, tools, I can see that I have a resource network interface with this fantastic name. And here it will give me the JSON for that resource. And this works for everything, even those that don't work for export as template. So this is amazing, but you might be wondering about how do I roll these things out to Azure. I can do that from PowerShell, like we've seen before, but that's not really scalable and automated. So the two things that I want to point you to. The first one is Deployment Manager. So, side remark, I've never used this before. That's because it's only 3 weeks old into preview. So I hope that exempts me from having to try it first myself. Because the complaint came in that we have these templates, and for example, for a high availability setup, we want to first roll them out to West Europe, then we want to wait 4 hours to see if anything hits the fan, and then we want to do it in another location, and we want to automate that whole operation. And that's not a thing you can do with ARM templates, with just ARM templates. So that's why they built the Deployment Manager. So what Deployment Manager allows you to do is create a lot of JSON that describes what is called a service topology, which is made up out of a number of services, and a service is a number of a Azure subscription you point to and a location. For example, my MSDN subscription in West Europe, that's a service, and my MSDN subscription in North Europe, that's another service. And within these services, I can create service units, which point to resource groups. So I can build up a topology of the infrastructure that I'm going to deploy on later. And I can specify one or more artifact sources. So that's the templates that I'm going to use in those service units. So this is really abstract. And next to this service topology, I can create what is called a rollout description. And a rollout description says, let's take this template and put it in these 2 service units. And then wait 4 hours. And then do a health check. And then take this ARM template and put it in that service unit. So this can do really the deployments that take a long time, span multiple subscriptions, span multiple resource groups, span multiple locations, and really fancy, also do health checks in between. And it cannot just probe Azure's own things, there are also a number of third-party health monitoring systems they integrate with. So this is really cool when you're into infrastructure. I think this is really targeted at the IT pro, people who manage big infrastructures. Yes?
What if I would like to, for example, have a little bit different resources in the Seraphim regions?
In the?
For a little bit different resources in the Seraphim regions, for example, for the pricing in the regions, or for example that I won't need one virtual machine in this region. What is the best approach?
So the question is, what if I want to have subtle differences?
Like enable, disable flag, something like that, yeah.
Yes, so for example, one's going to be the primary and one's going to be the secondary, right? And the primary you want scaled up, and the secondary you might take the risk to have it scaled down and only scale it up on demand. Which is, by the way, a risky endeavor, because everybody is going to do it at the same time, and not even Azure has a limitless performance. But let's say you want to do that. You can point to other templates per service unit, and you can also specify other parameter sets. So if you want to, for example, have a template that goes to, you want to make subtle differences between two things, I would use one template and then have a parameter, which is primary or secondary, or the SKU size. That's what I would do. Sure thing. But I think that for developers, there is another thing we can do. And I wanted to show you that as well. So, like I show you, in most of my solutions, next to my code, I have the infrastructure that it runs on. So this is an example, but I've got another one here as well. So this is a bigger application. Here I have all my ARM templates, and here I have a lot of code below. So if we put this in the same repo, we can also start working with this in the same build and release pipeline. So here is my build that comes with that source code. And as you can see, I am doing a bit of compilation for my NuGet. I'm putting NuGet, I'm restoring it, building it, testing it, and I'm publishing the code. And then I'm publishing it as an artifact. But what I'm doing in between, I am copying my ARM template from the sources folder to a staging folder, packaging it up as another build artifact, just as my code, and publishing that from the build. Which means that I can pick it up in the release as well. And my release is not just going to deploy my code, it's also going to deploy my infrastructure. So while this interface slowly loads, this is the deployment of my application. So this part you were probably not surprised by. This deploys some code, and this deploys some code as well. I'm even doing an application insights annotation. My operator is going to be really proud of me. But at the front, I'm deploying my ARM template right from that build artifact, and I'm doing incremental deployment. This means that I'm going to add everything to Azure that's in the template but not in Azure, and everything that differs is going to update Azure with what's in the template.
Before the code, or?
Yes, this is before the code, but this is only additive or updating. This is not removing anything. And that's with the reason, because my code might be, the still running code might depend on something that was in the previous template.
Yeah, because you said that the template is something else that is going to disappear when you go.
Yes, so the remark is that I'm going to roll out the new template that doesn't have a queue, that the old code is still running on, I'm going to be in trouble. So this is why I run this only incremental to only add things or update things. So there's still a little risk, but at least not the complete disappearance of resources. The next step that I'm going to do is I'm going to fetch the outputs from my ARM template back to the variables of this build. So instead of specifying the name of the web application that I'm deploying to, I'm referring to a variable that's coming back from the ARM template deployment. So the variables that I provide to my template are going to propagate through my complete release. I'm not hard coding the same name over and over again. So I can even generate a random app service name. And that's really interesting if you want to spin up and destruct environments, for example, for every pull request. And finally, only at the end of it, I am going to do a complete deployment of my ARM template to make sure that there are no changes of resources left over from earlier deployments, and that anything that somebody created that I don't want there is removed as well. I think that this combination of infrastructure and code deployment is really great for us developers. So there were two more things I was going to talk about. First of all, RBAC, role-based access control. One of the things that Azure Resource Manager also does is manage who can do what. And I think, yes, I didn't make any PowerPoint out of this, just let's do it in the portal. It's not that difficult. So for every resource in Azure, every subscription, resource group, and every resource, I can specify what we call role assignments. And a role assignment is a combination of a user, a resource, and a role that you can perform on that resource. And that role can be things like contributor, which means read-write, can be a reader, which means read-only, and it can be owner, which is read-write plus giving others access. And if we specify it on a resource group, it's of course going to descend to all the resources as well. And if I specify it on a subscription, it's going to go to the resource groups and all the resources. So every resource has a tab called Access Control. And here I can see a list of all the assignments on this resource. So looks something like this. I can create a new one. Very straightforward. But what's also really interesting, because I have this cascading down, I can also just type the name of any user and see its actual rights on this specific resource. Well, this is really useful, and a lot of high-end AM tools don't have that, and that's really powerful to see what somebody can do with this resource. And like I said, there are a number of roles. And each role specifies what we call a series of actions that you can perform on a resource. And there are built-in ones like contributor and reader, but we can also create roles of our own. So what I wanted to show you is that once I am connected to a Azure subscription, I can execute a command which is called get Azure RM role definitions, which is going to throw an exception. Awesome. That's new. Okay, let's try something else. Anybody played with the Windows terminal yet? It's cool, isn't it? Let's see what this does. You're not too fussed about it?
I have to go there when things get relevant.
Okay, so that's not working either. Let's try something else. Log in Azure RM account. So never, never, ever pick a password that you can remember yourself. And as Eric can test, it's going to take a while. Okay, this seems to be working. So let's pick the correct one. Hooray! So there are a lot of predefined roles, and some of them are pretty fine-grained. For example, you're an Azure Service Bus data center. Only allows you to put new messages on the queue. But if you want to be really clear on what a role can do, we can pick up the details of one specific role. In this case, reader. I'm going to convert the output to JSON. And I'm getting, again, a JSON object that specifies an array of all the actions that I can perform. So that's going to refer back to a resource provider, then a resource type, and then a series of operations like read, write, list keys. So here it's going to be */read, which means read everything. And if you want to see the...
Everything below Azure Resource, right?
Sorry?
If you assign
Mhm.
to a resource,
Yes.
and then you will have read on that resource.
So
Starting at that resource.
yes. So the remark is if I assign this role to somebody on a resource group, of course that read everything is only going to apply to that resource group and all the resources in it. It's not going to apply to the whole of Azure or your complete subscription. So it's made up of a series of actions. And what I can do is execute this command. It's called get Azure RM provider operation. I specify a resource provider and a resource type. And what it will do return me is a list of all the actions that the resource provider supports. So for virtual machines, there are pretty fine-grained operations. For example, to, I don't know, get a list of the virtual machine extensions, or to read the current state in the Azure configuration. Now, wouldn't it be awesome if we could create our own fine-grained roles out of this? Well, we can. What I've done here is I've prepared a file called rebooter.json, and this is a role that I created myself, and if I assign this to somebody on a VM, he can reboot this VM. I think he cannot even list the details of that VM, but he can reboot it. So when I have a service desk that regularly gets calls at night that need rebooting of a virtual machine, well, first of all, I got to find a structural solution. But secondly, to prevent keep getting called out of bed, I can assign them the very, very fine-grained right to reboot that virtual machine. And now this is not really a useful example, but you can imagine that it might be useful to create specific things like this. So what I can do is I can create a new Azure role definition. I point to the JSON file, and it creates this new role for me. It should create this new role for me. Okay, so I move things around, apparently. Since we're running late, I'm going to skip that. I can find that role definition again, then I can get its ID, and I can assign it to people just like any other role in Azure. And so when it comes to authorization, often people ask, which authorizations should I assign to people? As a developer, I take this stance. For the test environment, everybody should be able to do everything. That means people and my deployment pipeline. For my acceptance environment, my pipeline is the only one with write access, and people should only be able to read things, to verify things. And in production, nobody should have standing access to a production environment. That should not be necessary in 2019. The only one with write access is my pipeline. So if I need to scale up something, do it in source control, wait that 4 or 5 minutes, and have it effected after a review by somebody else. Now, of course, this is really important. It are your resources. If there is ever something really, really important going on, you should be able to provide yourself with access, but you shouldn't have standing access. Yes?
It should be done on kind of the rule of the promotion, so pipelines shouldn't... Sorry, one more time. It should be done on the rule of the promotion, so kind of the test environment should be promoted to the acceptance, or they can or they should have a different pipelines, because they are mostly differs by the variables or variables of the scale size. Yeah. So
the question is, how do you do a deployment to acceptance? Does it have a separate pipeline, or is it a promotion from test? In my opinion, of course, it is a promotion of test. But this means that within your, assuming Azure DevOps environment, you're going to provide 3 service endpoints. 1 to the test resource group, 1 to the acceptance resource group, and 1 to the production resource group with the appropriate assignments. And you're going to use them in the correct stages of your release.
But it's safe, right? It's safe, that approach. Safer, I would say.
I think, and I think this is an opinion of mine, that it's safer to have your pipeline deploy to your production environment than have a person do it. Yes. Okay. But of course, when you start with this, you might run into a number of kinks. Things might go wrong, but the repeatability and the fact that once you fix a mistake, it should not happen again, is much better than what a human can do. But again, it's an opinion. So the last thing that I wanted to show you, and I'm going to just touch upon it, is policy. Because what we have seen is the amazing things that you can do with templates. What we have seen is how you can limit what somebody can do, of who can do things, authorizations. And what we now also need to explore is if we can somehow limit the things that people can do. So for example, I want everybody to be able to do everything in Azure except for creating virtual machines, because I'm a big hater of virtual machines. I can do that using Azure policy. I can specify a policy that nobody should be able to create virtual machines. So with Azure policy, we can do three things. We can either audit things people do or we don't like. We can deny it. You want to create a virtual machine, deny it. And what the coolest thing is, we can automatically augment it. So for example, when somebody deploys, I don't know, a SQL database, we can automatically deploy another template that will enable diagnostic logging, if we think that that's helpful. Again, JSON, so pretty boring, and I think you're really JSON tired by the end of this evening. But what you can see is there's a lot of like boilerplate, but in the middle there's a policy rule. So before we dive to the policy rule, again, a policy is just a resource governed by a resource provider called Microsoft authorization. This is the policy rule. I specify whenever a deployment comes in that matches a specific condition, which is the if part, there's the thing that I want to do, the then part. So whenever somebody creates, in this case, a classic storage account, which is still under the ASM model instead of ARM, which is really bad, I want to audit it so that it gets flagged and I can generate reports out of it. Now policies can be assigned not only on resource groups and subscriptions, but also on management groups. So for example, if I have mimicked my organizational structure in management groups, I can say these people over there in the Netherlands, they are not allowed to use virtual machines. They have to go serverless, because people in the Netherlands are awesome. And that's really the last thing that I wanted to talk to you about. I can show you a little bit more if you want to, but it's all going to be JSON. So if you're up for it, feel free to ask. Or otherwise, thank you very much.
How, let's say if there's something just error occurred or something in your template, is it easy to fine tune the reason what happened, or just what is the reason just the template is failed? And yeah.
Sure. So is it easy to debug a failed deployment of an ARM template? It should be. Sometimes you get really good errors, and sometimes they are really cryptic. And the reason is ARM is going to pick up every resource part, strip it down, recreate the URL we saw at the start, and it's going to call into that specific resource provider. And the errors you get back are as good as that specific resource provider is giving you. But what you can always find is the following. When I go to a resource group, I can, on the top right, see deployments. So when I open that, I get a pretty structured breakdown of all the resources requested. And I can even click on one. Not the thing I wanted to see, this one. And then I see even more details about whether it succeeded or not. And if there's an error here as well. But what I was looking for, you used to be able to view this as a JSON file as well, which was really detailed and showed you pretty much just the whole exception that came back from the underlying resource provider. You get the same thing as well when you run it through Azure PowerShell.
Maybe you can download deployment details download.
I saw the word download somewhere as well. It's also new for me.
Only you get that one when there's an error, not when it's succeeded.
Oh, is that changed?
Yeah.
Ah, okay. Used to be.
If you go to activities, On the resource group, it's got an activity section.
The activity log, yes, that's another thing that you can use. But it used to be when you click on this operation details, there used to be a separate tab which contained all the details in a really big JSON file. And that was removed apparently.
It's there when you need it, so.
Okay, cool. The other thing is the activity log. This contains the full audit log for this resource or resource group. So that's going to contain all the management operations. It's also going to contain the restarts of VMs, reconfiguration, etc. But it's also going to contain the deployments. So for example, I think this update resource group is a deployment. And then we can find this fantastic JSON, which has all the details. But once you're down to this, you're really desperate. So I hope that answers the question. Any other questions? Yes, throw him a thing.
What do you think of services that maybe provide a more declarative approach to this, like Terraform or the serverless framework, where you don't go into the low level of building the JSON yourself, you define maybe at a higher level of abstraction?
Yeah, so there are a number of abstractions nowadays on top of ARM. Terraform, I think, is pretty much getting there. There's Ansible also nowadays has some roles for different Azure resource types. There's also another thing called Pulumi, I think. If Michael is watching, he knows it's much better than I do. And that's even programming style-ish, so you can do things like loops or repeat statements. I think that's a really powerful way, but we started using declarative things to get away from having to program. But I think if you want to start quickly, they are more powerful. They will take less time. But if you want to do things like reverse engineer what's already there and continue from there, I think you're stuck with ARM. So it both has its pros and its cons. And I don't think there's like a better. Sorry.
I don't know if I missed it. Is there a kind of a download functionality where you can get your current state of all your settings at this time?
Yes. Almost everywhere there's a thing called export template. And then what it will do, it will generate the template for that resource or resource group. Sorry?
Except your standard error message on top.
Ah, there it is. So sometimes it cannot reverse engineer all the resources.
Sometimes.
Okay, almost always it cannot reverse engineer all the resources. It used to be pretty good, but I think it changes over time, of course, depending on new things coming in. And then you get this warning that a 3D resource type could not be exported. So you know that this resource is not complete. But as we saw before as well, sometimes this error message is even failing. So just blindly reverse engineering it and then applying it might not work. But we also saw this other thing called the Resource Explorer, which is where I can drill down to every resource in its JSON form. And this is where there will always be everything. Even really small things like dashboards or alert rules, things that will not appear by default in a resource group are still here. And
But will it be complete?
yes, this will be so complete that all the defaults are in there as well. So for example, if you look up, I don't know, an app service, you're going to get this, which is almost all defaults except for this 3 lines on top. So you will really get everything. And I am an idiot that I didn't show you this. There's a thing called GitHub ARM templates. And the quick start templates, there are like 500 or 600 templates to start from and play with and to see how they work and interact with each other.
These are the ones you also get when you do file new in Visual Studio, right? In mobile.
Yeah, it should be, but for some reason, I always only get the same 20 or so. Because when I go here and go to resources and add new resource, this takes a while. And as far as I know, it's now going to that GitHub repo. and fetching the ARM templates. But this list is noticeably shorter.
Yeah.
What if you search?
Oh, sure, data lake. Yep. But I might be mistaken. This is reverse engineering in my mind. It's not something that I've read somewhere. Anyone else who wants to see more JSON? Nobody? Then I suggest we move back to Eric.